Hey guys, welcome to our video notes on simplifying radicals. If you notice a lot in this unit, we are solving a lot of radicals, especially dealing with the Pythagorean theorem. We need to make sure that when we're not giving our exam answers in decimal form, that we're giving it as a simplified radical. So a radical or square root is simplified when it has no square factors. We must also rationalize the denominator. So we need to see if there are square factors. So here in example 1, square root of 28, I see a perfect square factor that divides into 28 is 4. So I break it up into square root of 4 times square root of 7 to square root 7. This might be ringing a bell to some of you now as we got into our first example. Here in example 2, square root of 75, the largest perfect square that I see as a factor is 25. Square root of 25 is 5, square root 3. 42, let's see, perfect squares are 1, which doesn't really help us, 4, 9, 16, 25, 36, 49. None of those are factors of this, so this is simplified. Square root of 3 times square root of 40, let's multiply that together to make it one whole square root first. And now if I try to simplify this, the largest perfect square I can think of that goes into 120 is 4. And so this becomes 2 square root 30. Square root 30, no perfect squares go into 30, so that is my final answer. And then here, now I have 3 coefficient in front of my square root. I need to simplify, so I'll leave that 3 in front. It's being multiplied by this radical. The largest perfect square that goes into 20 is 4. 4 times 5 makes 20. The square root of 4 is 2. We don't know what the square root of 5 is. Now I can multiply these two coefficients. 3 multiplied by 2 is 6, square root 5. Okay, so we're looking for perfect square factors to simplify radicals. Let's move on to the next video.